So let's start setting up our DOP network. And I'm going to start with pressing tab and type in .NET. And I'm going to drop down an empty .NET right here. And obviously you can use the shelf tools if you want to, but I prefer not to use the shelf tools. But because, first of all, using shelf tools will give you a lot of unnecessary nodes. It would make your scene messy, clunky, and it just doesn't work for me. And that's why I like to keep things simple, and I like to drop down my nodes inside the .NET manually, because it also gives me an understanding of why Houdini is doing what it's doing. Okay, so inside the .NET, I'm going to drop down a bunch of nodes, starting with flip object and a flip solver, and obviously last but not the least, gravity. And I'm going to connect the output of my flip object to the first input of my flip solver, which is fluids to solve, the output of my flip solver to the gravity, and gravity to my output. And you can see as soon as I connect these nodes together, there is an empty container sitting at the origin, just there, not doing anything. And if I click play, it's not going to do anything either, because there is nothing in there. And that has to do with the flip object, and under the initial data tab, the input type, which is set to surface SOP. Now, this should be set to particle field, and it expects, after you set it to particle field, it expects a SOP path, which is going to be our ocean source node. So just to make things clean and simple, I'm just going to say out points. All right, and inside the .NET, I'll call those out points. And you can see that we have our particles here. However, that bounding object, this box, is still sitting at the origin, and that's not what we want. Because if I play this, so there's a lot of points there. So let's just decrease the number of points. So let's say 0.2. Okay, so that's going to decrease the number of points to 28 million. Nope, that's not what I wanted. I decreased it. So it was 0.67. So let's put it to 2. And that's going to give us 28,000 points, roughly. And what I'm going to do to keep everything clean and procedural, copy this parameter, and I'm going to say paste relative references in the particle separation, because they're essentially the same settings. One is at the SOP level and one is at the DOP level. Now, obviously, I can type 2 here as well, which is going to give me the exact same output. But just to keep things procedural, I would like to say paste relative references. Now, if I have to change this value now, I know for a fact that the value inside my .NET will change automatically. All right, and then under the guides tab and under the particles tab, I would set my visualization from default, which is set to sprites, to particles. So our particles look like that. So now what happens if I play this? Well, that's going to happen. My particles are going to go inside, limit themselves to inside that box that we have here, and they're going to go down and they're going to sink. Okay, how can we fix it? So under the flip solver tab in the volume motion, there are a couple of parameters here, the box size and the box center. And I'm going to go to the size and the center values of my ocean source node and say copy parameter onto my size and paste relative references onto the box size. And I'm going to do the exact same thing with the center as well, copy parameter and paste relative references. So now if I play this, you can see, because our box is exactly the same size as our bounds that are generating our points, it's not going to change the size, or it's not going to change the dimensions of my points, but it still sinks. The particles are still sinking. And that has to do with the closed boundaries. So if I have to go ahead and check on closed boundaries, what Houdini would do, Houdini would treat each and every boundary, i.e. the y, so this is minus y, this is plus y, this is plus x, minus x, and that's plus z and minus z. It would treat each and every one of those boundaries as a collision object. Now, we don't really need the plus y because a fluid is never going to reach at the boundary there, and even if it does, it's okay, it can come back down or we can delete it later, but in this case it's not going to. And yeah, that's how you set up our basic flat tank inside the DOPNet. Now obviously there is a couple of ways you can change things here as well, i.e. the narrowband particles, which is a very important setting, like without narrowband. So I think narrowband was introduced in Houdini 16.5, and it's a really important aspect of doing a fluid simulation since then, and it's such a great thing to implement into our fluids. So we'll talk about that in the next video, but yes, we have our flip particles here, our flip solver here, and in the flip solver under the particle motion I can say add ID attribute, so each and every point will have an ID, which is great, which is how it should be. And then in the vorticity tab, I would say add vorticity attribute as well. Now vorticity is just like velocity, but what it does, it takes the curl of the velocity and it computes that. Essentially every fluid sim will be calculating vorticity, but it would not be saving it out. But by saying that add vorticity, by checking on add vorticity attribute, what it will do, it will save out your simulation. It will save out the vorticity attribute as well, along with, let's say, velocity, position, and a bunch of other attributes. And it's always a good idea to save the vorticity attribute out, because then you can use that attribute to like smooth some stuff, or you can use that attribute in the whitewater source and whatnot. So it's always a good idea to save that attribute out. However, if you're running low on disk space, I would suggest you don't save the attribute out, because essentially it's not calculating anything extra, but it's definitely saving extra on the disk. So now let's talk about on how we can set up our narrowband